On August 26, 1883, an island in the Indian Ocean didn't just erupt, it erased itself from the map, and the sound traveled faster than anyone thought possible. What you're looking at here is a collection of barometer readings from that morning. See how they're all marked and annotated. These instruments recorded something scientists had never witnessed before, a pressure wave so violent it circled the entire Earth not once, but 7 times. The eruption of Krakatoa didn't just change the island, it changed how we understood sound, energy, and the planet's interconnected systems. We're counting down 5 ways this single eruption reshaped our world. And I promise you, by the time we reach number 1, you'll understand why this disaster matters more than most people realize. Let's start at number 5. Number 5, the sound heard round the world. The initial explosion occurred at 5:30 in the morning local time. In Rodriguez Island, nearly 3,000 miles away, people heard it clearly. They thought cannons were being fired nearby. The blast was so loud it ruptured eardrums on ships in the Sunda Strait. This wasn't just noise, it was the loudest sound ever recorded in human history. What makes this remarkable is what it proved. Sound travels through air, yes, but this explosion demonstrated that pressure waves could be tracked, measured, and predicted. Meteorologists suddenly had a tool. They could use barometers to detect distant storms and volcanic events. The Krakatoa eruption became, in a sense, the first global seismic event we could actually measure in real time. Number 4, the tsunami that drowned entire cities. The eruption triggered waves over 100 feet high. The coastal town of Enya was obliterated. Around 36,000 people died in the waves alone, more casualties than from the blast itself. Entire communities simply vanished. Ships were carried inland and deposited miles from shore. The ocean became a weapon more devastating than the volcano. Here's what's unsettling about this. The survivors couldn't explain what happened. Witnesses described the sea retreating, then rushing back with impossible force. Some thought the world was ending. We now understand this as classic tsunami behavior. The pressure wave pushes water away before it crashes back. But in 1883, no one had a framework for understanding it. The disaster rewrote tsunami science. Number 3, the year without a summer, 2 years later. Look at these temperature records from 1884 and 1885. Global temperatures dropped by as much as 1-2 degrees Celsius. Crops failed across North America and Europe. Harvests were devastated. People called it the year of the cold summer, but the volcano's real impact lasted much longer. Ash and sulfur dioxide particles circled the atmosphere, blocking sunlight. This wasn't just an inconvenience. Economic reports show grain prices spiked. Famine threatened regions. People starved because a volcano erupted 5,000 miles away. The eruption proved that local disasters have global consequences. It was perhaps the first time humanity saw evidence of planetary interconnection through climate. We were living in a closed system, and we finally had proof. Number 2, the red sunsets painted across continents. For months afterward, sunsets became impossibly vivid. Reds, oranges, and purples saturated the sky everywhere on Earth. Artists painted them. Poets wrote about them. Some people thought it was beautiful. Others thought it was a sign of the apocalypse. We now know the suspended ash and sulfur particles were scattering light in unprecedented ways. This phenomenon had real scientific value. Scientists tracked the sunsets across latitudes, which helped them understand atmospheric circulation patterns. The eruption essentially created a global laboratory. We learned how particles move through the upper atmosphere. It was disaster as data. Tragedy became a teaching tool. And that brings us to number 1, the eruption that proved volcanoes could alter global climate. This is the big one. This is why we're still talking about Krakatoa 140 years later. Before 1883, scientists didn't fully grasp the connection between volcanic eruptions and global temperature shifts. They had theories but no proof. Krakatoa gave them proof. The eruption injected roughly 80 million tons of ash into the stratosphere. It released sulfur dioxide that formed sulfuric acid particles, what we now call volcanic aerosols. These particles reflected sunlight back into space. The planet cooled. Here's what makes this truly significant. This understanding shaped how we now think about climate change itself. When scientists study how the planet responds to atmospheric particles, they often reference Krakatoa as the baseline case. It's the historical experiment that taught us volcanoes are geoengineering agents. They can cool or warm the planet. One eruption, and we suddenly understood planetary systems differently. The eruption also killed around 71,000 people directly or indirectly, but its legacy isn't measured in death tolls. It's measured in knowledge. The Krakatoa eruption forced science to expand its understanding of how the Earth actually works. It connected geology to meteorology. It proved that what happens on one side of the planet affects everywhere else. This telegram right here, dated August 27th, 1883, was sent from Java to Europe. It's one of the first reports of the eruption transmitted across continents by electrical wire. The speed of communication had finally caught up to the speed of disaster. By the time people in London read about Krakatoa, the island was already gone. Information traveled at the speed of electricity, not ships. The world had shrunk. When you understand Krakatoa, you understand why we study volcanoes today, why we monitor volcanic activity globally, why climate scientists care about aerosol particles, why we track atmospheric pressure. The eruption created the template for how we respond to planetary-scale disasters. One island, one morning in August, changed science forever. The exhibits here represent more than historical curiosity. They're evidence of how humanity learns. We stumble through catastrophe, and sometimes, if we're paying attention, we emerge with understanding. Krakatoa gave us that. A disaster became a doorway. Subscribe so you don't miss the next disaster that rewrote history. There's one every week on this channel.